Good morning. This is Ms. Billerbeck, and we are going to talk about key features of a quadratic function. So first we need to talk about the quadratic parent function, which is f of x equals x squared. So in this case, the parabola that this function makes is upward. So the parabola is opening upward. Okay, we also see that the parabola has a vertex at this point here at the origin, which is 0, 0. And it's the lowest point of this parabola, so it's called the minimum. We also see that here's the y-axis, and these points are balanced around the y-axis at an equal distance. So we have 1, 1, negative 1, 1. 2, 4, negative 2, 4. So this y-axis is acting as an axis of symmetry. So in this case, the axis of symmetry would be defined as with an equation as x equals 0. Even though that's counterintuitive, that the y-axis is x equals 0, it is true. Now let's look at this equation. When the values of f of x, when are the values of f of x positive and when are the values of f of x negative for a equals x squared? So let me share the screen. All right. So we have this graph here, and we have the parent graph right here in green. Now I've changed A here, so we can just play around with A and see what happens when A gets to be a larger number. So it stretches up toward the y-axis as A becomes a higher and higher number. Now let's go back to 1 and make it the parent graph again. Well, I almost have it at 1. There. Okay, so now we have a certain range here where x becomes less than 1 but greater than 0. So this becomes a fraction. I call it's like a rosebud, and this is like a wilting rose. It becomes a fraction of its beauty. So it wilts toward, it wilts toward the x-axis. Now, right at 0, we see, well, that's not a parabola at all. That's a straight line. So that's the x-axis, and it's defined as y equals 0. So we rule out a equals 0 when we're talking about parabolas. Now, as soon as a becomes negative, look at that, it reflects below the y-axis. Okay, and as we approach -1, it starts getting closer to the y-axis. So it's still in compression in this area here and to here. Let's see. Before it gets to -1, that's considered a vertical compression because it's still farther away from the y-axis than the parent, or the parent reflected. So here we go, we get to -1, and now we have just a pure reflection of the parent function there. But as we increase our negativity, we stretch toward the y-axis again. And so that as it gets closer to the y-axis, it's called a stretch. And as it gets farther away from the y-axis and closer to the x-axis, then it's called a vertical compression. All right, so let's go back and answer our questions now that we've explored this. So our questions are, when are the values of f of x positive and when are they negative for f of x equals a of x? So we discovered when the parabola is up like this, whoops, well, that's a bummer. Let's change that up. Okay, so there we go. So when the parabola goes up like that, that means A is greater than 0. When the parabola goes, so if we have the x-axis here and the y-axis here, that's what that looks like. But when we have A going down like this, that means, or not A, but the parabola going down like this, that means A is less than 0, so we have a negative value. A negative value of A for f of x to have a negative, be a negative output. And this would be a positive value here. And then if we have a positive value of A, we'll have a positive output. If we have a negative value of A, we have a negative output. How does the sign of A affect the domain and range? All right, so the domain is the x value. So the domain's going off like this forever, and it's going off like this forever, no matter whether A is positive or negative. So the domain for both conditions is all real values. For both conditions of A is all real numbers, abbreviated with this fancy symbol here for all real numbers. I can't fit numbers in, so, well, I'll put it down here. Numbers, there you go. Okay, so the range, though, is different. So we have two different ranges. We have the range that is f of x is greater than or equal to 0. So for A is greater than 0, then f of x is greater than or equal to 0. But then we also have, if A is less than 0, f of x, the output will be less than or equal to 0. So they both can be 0 because the vertex for both conditions are at right here at 0, 0, the origin. But the output for this one is all negative, and when A is less than 0. So f of x will be less than or equal to 0. The output for A is greater than 0 will always be f of x is greater than or equal to 0. All right, so a function of the form g of x equals ax squared increases over the interval ax is less than 0 and decreases over the interval x is greater than 0. Okay, so let's quickly do a quick sketch. There we go. So this is saying it increases when x is negative. So it's increasing like this when x is negative. Okay, and it could also be looking like this. It doesn't have to go through the vertex, by the way. Okay, so then we see it decreases over the interval when x is positive. So x is positive in this region and x is negative in this region. So that means at this point, it's decreasing like that. So then it says, what is the possible value for A? So that would make A less than 0. So it's negative. Okay, so that would be the way that it would open downward. Okay, so that would mean it would increase if X is in the negative region, and it would decrease as X becomes more positive. All right, let's look at the next example. Okay, so we have a dance studio is installing a new hardwood floor for $8.75 per square foot. How much will the new flooring cost for a 17 by 17 square foot studio? So if we have, let's call it S of X since it's for a studio, and we see it's $8.75 per square foot, per 1 square foot. So then we're going to multiply by X squared, where X is in feet. Well, let's say X equals length in feet. So X squared would be feet squared. So we have feet squared on bottom, we have feet squared on top. Okay, so you always check your units to make sure that they cancel. So feet squared cancels feet squared, so we're going to have dollars for our output. All right, so let's see what happens if we have S of X equals, oh, it's not going to be S of X, it's going to be S of 17, because X is 17, equals $8.75 per square foot. We could just put feet squared like that. And then we're going to multiply by 17 feet. And we're going to square it. So that's $8.75 times 289 feet squared. So our final value then for that will be $2,528.75 when we multiply that out. Okay, so as we increase our square footage, that means our cost is going to increase for the flooring, and that completely makes sense. All right, let's take a look at the next one. So how do the average rates of change for f of x equals negative 0.5 x squared and g of x equals negative 1.5 x squared over the interval negative 5 is less than x is next than 2 compare? So what we want to do first is take f of x equals negative 0.5 x squared. And we want to evaluate it for this interval. So first we're going to take f of x equals negative 5. Our f of negative 5 equals negative 0.5 times negative 5 squared. So that's going to give us negative 0.5. And that's negative 5 times negative 5 is 25. And 0.5 is a half. So that's going to be negative, and half of 25 is 12.5. So that one will be negative 12.5. Okay, so now let's take negative 2. So f of negative 2 equals negative 0.5 times negative 2 squared equals, and we have negative 0.5, and that's going to be times negative 2 times negative 2 is 4. Half of 4 is 2, and we have a negative sign, so that's going to be negative 2. So now we're going to take that average rate, because we have two y values and two x values, so that we can find an average rate of change for that. So our average rate of change will be, we're going to take the f of x output. So we have negative 2 minus a negative 12.5. And we're going to put that one over, our output was negative 2 and we started with negative 2. Isn't that crazy? So we have negative 2 minus a negative 5. So this is going to equal, and we have two negatives make a positive. So this is going to be 10.5 over, and then this is a positive again, two negatives making a positive. So we have 5 minus 2, which is 3. All right, so our average rate of change for this is 10.5 divided by 3. And that ends up being 3.5. All right, so now let's take a look at g of x. So g of negative 5 equals, and we have negative 1.5 times negative 5 squared. So this one becomes negative 1.5 times 25. So this will be 25 plus half of 25, which would be that. So this is going to be negative 37.5. So that's the easy way to calculate 1.5. Take 25, then half of 25, and then you add it together. So g of negative 2 then will be negative 1.5. And we're going to write negative 2 here squared. Negative 2 times negative 2 is positive 4. And 1.5 of 4 is 1, 4 is 4, plus half of 4 is 2, is 6. So that's negative 6. So now let's look at the average rate of change. I'm going to abbreviate average rate of change as average rate of change, just to spare some room. So average rate of change equals, and then we have our output. Let's do negative 6 minus a negative 37.5 over negative 2 minus a negative 5. So two negatives can make a positive. So 37.5 minus 6 is 31.5. And then we're going to divide that. And this is 3 on the bottom again. And if we divide that by 3, there's 1, 3, and 3. There's 0, 3s, and 1. We're going to bring the 1 back over here now. And there's 5, 3s, and 15. So we see that the average rate of change for f of x is 3.5. And the average rate of change for g of x in that same interval is 10.5. So this one's changing faster than this one. So if we look at the value of a, we see, well, that makes sense because g of x is a is bigger than f of x is a. So by 3 times. If we multiply this by 3, we would get this. So this is 3 times increasing 3 times or decreasing 3 times faster than this one, which means its rate of change is just going to be a greater rate of change. Okay, but over this period in the negative region, remember if it's a negative value, we have the parabola opening up downward. So we're doing our rate of change in this area here, where as x increases, f of x increases. So that's why we're getting a positive rate of change for that region. Isn't that interesting? So we would expect in this region, we'd have a negative rate of change. All right, that's it for today. Have a wonderful day. Bye-bye.